મિત્રો, ઇન્ફાઇનાઇટ સિક્વન્સ એન્ડ સિરીઝ ઘણી રોજબરોજમાં આપણે યુઝ કરતા હોઈએ છીએ. તો આજે આપણે સમજવાનો પ્રયત્ન કરીશું કે ભાઈ વોટ વી મીન બાય એ સિક્વન્સ એન્ડ વોટ વી મીન બાય એ સિરીઝ, અને સાથે એની ખૂબ રસપ્રદ જે પ્રોપર્ટી છે એના વિશે પણ આજે અભ્યાસ કરીશું. આપણને પ્રશ્ન થાય કે વોટ વી મીન બાય એ સિક્વન્સ. ફોર એક્ઝામ્પલ, એક ટેબલ મૂક્યું છે, એની બાજુમાં 4 ખુરશીઓ છે, બીજું એક ટેબલ છે, એની બાજુમાં બીજી 4 ખુરશીઓ છે. આવી કોઈ એક અરેન્જમેન્ટ છે. તો આ અરેન્જમેન્ટ પણ એક સિક્વન્સ છે. આપણે જોઈએ કે ઘણી જગ્યાએ દિવાળીમાં લાઇટની અરેન્જમેન્ટ હોય છે. તો લાઇટની અરેન્જમેન્ટમાં બી અમુક કલરના આ લેમ્પ છે, પછી બીજા કલરના લેમ્પ આવશે, પછી ત્રીજા કલરના લેમ્પ આવશે. એમ એક કોઈ ચોક્કસ નિયમના આધારે એની ગોઠવણી હોય છે. તો આવી ચોક્કસ નિયમના આધારે કરેલી ગોઠવણી એટલે સિક્વન્સ. રોજબરોજમાં બી કંઈ વસ્તુઓને મૂકવાની હોય ત્યારે બી આપણે કહીએ છીએ કે ભાઈ આને સિક્વન્સમાં રાખો, આ કેમ આડાઅવળું મૂક્યું છે. મીન્સ સિક્વન્સ એટલે એક ચોક્કસ નિયમના આધારે પદાર્થની ગોઠવણ કરેલી હોય અથવા તો ઓબ્જેક્ટ્સ. સો અરેન્જમેન્ટ ઓફ ધ ઓબ્જેક્ટ્સ બાય અ ડેફિનેટ રૂલ that we call it a sequence. આના ઘણા બધા એક્ઝામ્પલ છે કે એમાંના 2-3 ઇન્ટરેસ્ટિંગ એક્ઝામ્પલ આપણે બોર્ડ વર્કમાં હું તમને બતાવું છું. તો હવે આપણે બોર્ડ વર્ક કરીએ. ત્યાં જોવાનું. હા 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 આપણે સૌ પરિચિત છીએ કે આ જે ટ્રાયેંગલ આપણને અત્યારે બોર્ડમાં દેખાય છે એ પાસ્કલ ટ્રાયેંગલ છે. એ પાસ્કલ ટ્રાયેંગલ બનાવવાનું આપણે સૌ જાણીએ છીએ કે આપણે 1 થી સ્ટાર્ટ કરીએ, બંને એન્ડમાં 1 લખીએ, 1 + 1 2 થશે, અને એ રીતે આપણે આગળ વધીશું. એન્ડ ઉપર આપણે 1 લખીશું, 1 + 2 3 થશે, 2 + 1 3, ફરી એન્ડ ઉપર 1 લખીશું, 1 + 3 4 થશે. એવી રીતે આ ટ્રાયેંગલ બનાવી શકાય આગળ. આ ટ્રાયેંગલની ઘણી બધી પ્રોપર્ટીઝ છે. બીજી વધારે પ્રોપર્ટીનું આપણે ડિસ્કશન નહીં કરીએ, પણ આની મદદથી 2-3 અગત્યની સિક્વન્સ મળે છે. એમાંની એક સિક્વન્સ છે ફિબોનાકી સિક્વન્સ. એ આપણને આ રીતે મળે. આવી રીતે આપણે એરો કરી દઈએ, and then if we add, then we'll get a sequence like this: 1, then again it is 1, then it is 2, and so on. This is known as Fibonacci sequence. The another example of a sequence is this. If you see this dot, this is 1, this is 1 + 2 3, so the next number is 3, then it is 6, then 10. So we will have another sequence. This is known as sequence of triangular numbers. So these are 2 very important sequences. There are another properties of Pascal triangle also, that with the help of Pascal triangle you may write the value of NCR. Even here you may have this sequence 1 3 6 10 15. This is the sequence of triangular numbers, and the sequence of Fibonacci number In general you may write like this: Fn is Fn minus 1, fn minus 1 plus fn minus 2, n greater than or equals to 3, and you will get the other terms. So, the now natural question arises, can we have every time a rule, and the answer is yes. If there is a sequence, then you have a definite rule for that particular sequence. So, mathematically what we mean by sequence is this: sequence is a function whose domain is the set of natural numbers. Now, we will see some of the slides for the further discussion, and we will continue a few more examples and properties in the form of slides. A sequence is a real valued function whose domain is the set of natural numbers. The numbers in the range of a sequence are called elements of the sequence. If f is a sequence, then f is usually denoted by the subscript notation sequence a n, where a n is f of n and n belongs to n. Next, a sequence a n is also denoted by listing its elements in order a1, a2 and so on a n. For example, f n2 r then is defined as f n equals to 1 by n is a sequence. First term of the sequence is 1 and the second term of the sequence is 1 by 2, third term is 1 by 3 and so on. In subscript notation, the function sequence f can be written as sequence 1 by n. Another example, let f n to r be defined by f of n equals to n upon 2n plus 1, where n belongs to n, then f is a sequence. Another example is f n to r be defined by sin n pi, n belongs to n, then this f is a sequence. A sequence a n defined by a n equals to c for all n, where c is a fixed real or a complex number, is said to be a constant sequence. Another is this, the sequence 1 1 1, this is another example of a constant sequence. And now the definition of decreasing and the increasing sequence. A sequence a n is said to be increasing if a n plus 1 is greater than or equals to a n for all n. A sequence a n is said to be decreasing if a n plus 1 is less than or equals to a n for all n. A sequence a n is said to be strictly increasing if a n plus 1 is greater than a n for all n. A sequence is said to be strictly decreasing if a n plus 1 is less than a n for all n. A sequence is said to be monotonic if it is either increasing or decreasing. It is clear that a strictly increasing sequence is increasing sequence and a strictly decreasing sequence is decreasing. Then we have now more examples of a sequence, and once you have a sequence, if you are writing that sequence, you may have its upper bound or a lower bound. So, the next definition is the number c is called a lower bound of the sequence a n if c is less than or equals to a n for all n. Similarly, a number d is called upper bound of the sequence an if an is less than or equals to d for all n. A sequence an is said to be bounded if it has upper bound and a lower bound. We may have many examples of this type of sequence. Let us prove that this sequence n upon 2n plus 1 is a monotonic bounded sequence. We may start with n plus 1 upon 2n plus 3 is greater than n upon 2n plus 1 for all n, and simplifying this we will have n plus 1 into 2n plus 1 greater than 2n square plus 3n. This is for all n. On simplifying we will get it 1 greater than 0. So, our supposition that it was bounded, that is that come to contradiction. Okay. Now, another is this sequence, it is monotonically increasing. So, we will begin with 2n plus 1 greater than or equals to n, and we will come to know that n upon 2n plus 1 is less than or equals to 1. So, 1 is the upper bound of the sequence an. Since all the terms of the sequence are positive, 0 is a lower bound of the sequence. This is thus the given sequence is a bounded sequence. We have both this upper and the lower bound. Next example is so that the sequence of natural numbers n is not a bounded sequence. Let us choose a upper bound. Let capital M greater than 0 be an upper bound of sequence n. Then integer part of m plus 1 is greater than 1 m, but integer part of m plus 1 is integer part of m plus 1th term of the sequence. This is a contradiction. Thus, no positive real number can be upper bound of sequence n, since all the terms of the sequence are, we have unbounded sequence n.
Thus, n is not bounded.
So, sequence n is not a bounded sequence. Next, we say that a sequence an is convergent if there exists a belongs to R that satisfy the following condition. For every epsilon greater than 0, there is n0 belongs to n such that mod an minus a less than epsilon for all n greater than or equals to n0. In this case, we say that sequence an converges to a, or that a is the limit of the sequence an, and we will write limit of an as n tends to infinity is a, or it is an tends to a. A sequence that is not convergent, it is said to be divergent. It is clear from the definition that a constant sequence C is a convergent and C is its limit. When sequence converges to some number, we call that number as a limit of a sequence. Now, we will have another example.
Sequence 1 by n.
Sequence 1 by n. This sequence is a convergent sequence and 0 is the limit of this sequence. We will have this proof that let us begin with epsilon greater than 0. Absolute value of 1 by n minus 0 less than epsilon. This is for all n greater than or equals to n0. Double implies 1 by n is less than epsilon for all n greater than or equals to n0. That double implies n is greater than or equals to 1 by epsilon for all n greater than or equals to n0. Now, if we choose n0 is integer part of 1 by epsilon plus 1, then definitely this n0 belongs to n, and n is greater than 1 by epsilon for all n greater than or equals to n0. Thus, what we have seen is this, that limit of 1 by n as n tends to infinity is 0. So, limit of this sequence is 0. Next we will prove that the sequence minus 1 raised to n plus 1 is divergent. Let us denote the sequence by a n. The elements of this sequence are 0, 2 and so on minus 1 raised to n plus 1. Thus, a n is having two values, either it is 0 if n is odd or it is 2 if n is even. Assume that the sequence is convergent. Let a be the limit of the sequence. Thus, for every epsilon greater than 0, there is n0 belongs to n such that the absolute value of minus 1 raised to n plus 1 minus a less than epsilon for all n greater than or equals to n0, taking epsilon equals to half, then this mod minus 1 raised to n plus 1 minus a less than epsilon for all n greater than or equals to n0. That means 2n0 is greater than or equals to n0 and 2n0 is an even number. Taking n equals to 2n0 plus 1, then n is 2n0. In the above inequality, we have minus 1 by 2 less than minus a less than half. Adding 2 in this will get minus half is less than 2 minus a less than half, and that gives on simplification that 3 by 2 is less than 2 minus a. This is a contradiction, as the value of